You have to know that humans have been using fossil fuels for a very long time. Coal, oil, natural gas, propane, diesel, or other stuff. What does fossil fuel even mean? It means fossil fuel. Fuels that come from ancient fossils. Fossils that come from animals and plants. Creatures in the ocean or on land. Anything that died in history, it could be in the water or on land, remained on Earth. You know that bacteria attack any dead body. The bacteria eat whatever they can, and the remains is left on the ground. The remains that was left on the ground stayed for millions of years, and it entered the Earth's crust. And today, that fossil has turned into fossil fuels. The most famous fossil fuel that everybody knows and loves is oil. The first oil drill happened in 1859 in the state of Pennsylvania. This oil drill didn't really have value because they didn't really know what they could use this stuff for. They would pull around 3,000 liters of oil a day, and it was kind of worthless because there was not a lot of buyers. They would turn it into kerosene and use it for old lamps. But today, 90 million barrels of oil a day is pulled out of the ground. There's a question now. What does the Persian Gulf have that there's so much oil in there? Was it a jungle? Did the dinosaurs live here? All these are wrong. Millions of years ago, the entire Middle East was underwater. But there was a lot of places that was underwater. Why don't they have oil? Because the Persian Gulf was a special place that pulled everything towards it. Millions of years ago, the Persian Gulf was considered a basin. And that means anything that was in the water would be headed that way, because a basin is kind of considered like a bowl, so everything is attracted that way. And that is why most of the fossil fuels like natural gas and oil is located in the Persian Gulf. Different parts of the world had this situation happen, and now they have fossil fuels. So if you get away from the Persian Gulf, you could say there's a lot of oil around Venezuela and Canada and the United States. We can't talk about the whole world, but we can put an example on Venezuela. This place, just like the Persian Gulf, was underwater, and it was also considered a basin. Venezuela was located in an area where all the bacteria, algae, plants, fishes, and any corpse was headed that way, and it was kept on the ground in that area. And that is why Venezuela, with more than 300 billion barrels of oil, has the biggest oil reserve in the world. After Venezuela, it's Saudi Arabia, which is around 266 billion barrels. These are oil that are very easy to access, and you can pull them out for a very low price. But there's another type of oil that it's between the rocks, and pulling it out is a lot more expensive. The process of pulling oil in between rocks or sands and dirt is called fracking, or it's also considered hydraulic fracturing. Fracking is not as easy as it looks, and it's not cheap to do either. If oil prices are low, it's not even worth it to do fracking, because pulling shale oil by fracking, it's around $50 a barrel. To pull oil in between rocks in the crust of Earth, first they insert a type of liquid that's mostly water, and it puts pressure on the rocks and cracks them. After that, oil or natural gas can be pulled out from it. But the cost to pull out oil in the Persian Gulf is only around $10 to $20 a barrel. Before the US could start fracking, they were dependent on the Persian Gulf oil, and they had to buy it from them. But with fracking, they could get their own oil. But each barrel has to cost more than $50, so it's worth to do all this work. You could say Canada has a lot of oil, and it's very similar to Venezuela. But Venezuela has very easy accessible oil. Canada's oil has to be pulled from rocks and sand. And that is why Canada is not on the list with the most oil reserve. So why does the US and Canada have oil in between the rock? Or Venezuela and Persian Gulf is very easy accessible oil? Because the age of the fossil fuels in Canada and the US are a lot lower than the Persian Gulf and Venezuela. Scientists say if you wait a couple million years, Canada and the US oil is gonna be like Venezuela or the Persian Gulf. But obviously they're not gonna wait because they're very impatient. Since the day I went to school, they were saying that in 30 years, there would be no oil left. But this 30 years is not moving, and they're always saying 30 more years. The more we move forward, the more oil we find, and the reserves get bigger and bigger. But the more we move forward, our need for oil is less and less, and the main reason is the environment. They say fossil fuel is causing global warming. Right now, they want to lower the use of oil and focus on natural gas, and that's another fossil fuel, but with very low emissions. You have to know that the cleanest fossil fuel in the world is natural gas, and getting a hold of it is just like oil. You could use natural gas for everything as well. Anything you can make with oil, you could make with natural gas. Like for example, plastic. As you know, we're going towards electricity, so the main usage of power is going to be electricity soon. And natural gas has a very important role in this situation. The technology is moving towards jet engines that create electricity. Just like this jet engine, and it's called a gas turbine. It uses natural gas and it creates a lot of electricity. And the cool part is that the exhaust that gives the heat makes steam, and that creates electricity. Nowadays, jet engines aren't only in the skies, but they're creating electricity on the ground. Electricity that comes from natural gas, and the exhaust heat creates electricity as well.
In our other videos, we have learnt how fractional distillation is used to separate hydrocarbons into fractions with a similar boiling point. In this video, you will learn the names of some of the most important fractions and their uses. As you are now aware, large hydrocarbons have higher boiling points and so are removed at the bottom of the fractionating column. Smaller molecules condense higher up the column. We will now take a look at some of the common fractions as we move down from the top of the fractionating column. Some of the smallest molecules are between 1 and 4 carbons in length. This fraction has such a low boiling point that it is still a gas when it is removed from the very top of the fractionating column. This fraction is known as refinery gas or bottled gas. Bottled gas because it can be stored in bottles under high pressure. You could well have seen bottles of propane or butane running barbecues or heaters in your home, and these are examples of the refinery gas fraction. Petrol is between 5 to 7 carbons in length. It is still a fraction of small chain hydrocarbons, and therefore these vaporize at a low temperature and are easily ignited. This makes it useful as a fuel in the internal combustion engine of a car or other vehicles. Naphtha is not such a useful fuel, but it is a valuable source of organic molecules which can be cracked to make more fuels or form alkenes. Alkenes can be turned into polymers, and polymers can make plastics which are used in our everyday lives. Kerosene has an important use as a fuel for jet engines, in aircraft and even in some rockets. Kerosene is also called paraffin in some parts of the world and is a common fuel burnt in paraffin or kerosene lamps used for lighting. Diesel is the next fraction. It is a common fuel in cars, vans and lorries. It is not as volatile as petrol, and instead of spark ignition, it ignites under compression. Below diesel are the residue fractions. Fuel oil is a fuel used in power stations and ships. Lubricating oil, which sticks to surfaces and reduces friction and protects from rust. And finally, waxes, which along with the oils can be used for polishing surfaces. The very bottom fraction is bitumen. This is a thick black adhesive used on roads, either as the surface finish or combined with stone chippings to create a solid, resistant material. It can also be used to cover roofs due to its waterproofing properties. All these fractions are separated from the crude oil mixture. To try and explain the importance of crude oil, consider these facts. There are estimated to be over 1 billion cars in the world, of which many will be using petroleum as their fuel. There are many million flights each year, each burning kerosene fuel. Not forgetting the massive plastic that is made and used each day for products and their packaging. Even the bitumen used to surface and resurface roads around the world. As you can see, crude oil contains many useful products that just need to be separated from the crude oil mixture. Now, at the end of this lesson, you should have a better understanding of why crude oil is such a valuable resource and the use of each of the main fractions.
Natural gas, a type of gas that has been buried deep in the ground, and recently humans have been able to pull it out and begin using it. We already knew that, but we want to see where this gas came from and why it is so important in our world today. Just like oil, natural gas comes from fossils. Producing natural gas, coal, or oil began 550 million years ago, when the fossils of different organisms died, buried, and slowly went to the depths of the earth. And it got buried so deep that oxygen didn't have access to it anymore. When it's buried this deep, the heat coming from the bottom and the pressure of the stone, rock, and sand that it's above it crushes it for millions of years. After all this time, these ancient fossils turned into a form of molecules called hydrocarbons. What is hydrocarbon anyways? This molecule is formed over time and it's basically natural gas or methane. Methane is invisible, it doesn't give off a smell, and it's very flammable. What you're seeing on the screen is the formula for methane. It has 1 carbon atom in the center and 4 hydrogen atoms surrounding it. When natural gas, oil, or any fossil fuel that's formed underneath the Earth's crust, it all depends on the surrounding rocks, how it's laid out. The more empty space these rocks have, the more oil and gas you can find under there. And that basically means the emptier the space, the bigger the reservoir. This mostly applies to oil and gas, but oil flows everywhere in terms of liquid. Between all the fossil fuels, natural gas is the lightest one, and that is why it's usually the highest layer. Like for example, in the Persian Gulf, which has the highest density of natural gas, most of that gas is close to the Earth's crust. And by Earth's crust, we mean underneath the seabed. And that is why it's much cheaper to pull this natural gas rather than other places. Like in Canada, the natural gas and oil is in a form of shale. And that means the gas and oil is stuck between sand and rocks. So the process of pulling it out is much more expensive. The most important fossil fuel right now is probably natural gas. It used to be oil, but natural gas has surpassed it. The most important thing is most of the electricity around the world is produced by natural gas. Most of the food that's cooked around the world is cooked on a gas stove. Even if it's an electric stove, the electricity is produced by natural gas. Most of the heater systems is with natural gas as well. And of course, some transportation vehicles also use it. On this planet, there is a lot of gas, and sometimes it releases it. Like this part of Turkmenistan, which is called the Darvaze. In the year 1971, the USSR was looking for natural gas in this area, and it was confronted in this area of Turkmenistan. The Russians bring supplies so they can start extracting the natural gas in this location. But once they started working, a sinkhole was created in this area, the one you're seeing. When this happened, the natural gas that was in this vicinity started leaking out of the ground, polluting the entire area. The gas was so bad that it was actually making the local population very sick. So the Russians figured it was a good idea to set it on fire so the natural gas burns rather than go to the atmosphere and pollute the air. The USSR could actually control the gas that's coming out of it, but it seems like they were lazy or they didn't want to spend any money controlling the gas, so they just chose the cheap route and set it on fire, which is why it is still on fire and they're not able to put it out. But let's get back to gas reservoirs around Earth. Just like we say, there is gas everywhere on Earth, but how do you find it? That's the real question. With modern tools, this job has become much more simpler. There are equipment that could send energy waves to the Earth's crust to see what's going on underneath it. And that's based on the energy wave that's sent back, bouncing off the ocean floor or the ground. The way the energy comes back to the ship or car or vehicle, it shows the engineer what's down there. Is it oil, gas, or is it nothing, or is it even water? Another way to check, but not recently, is to drill the ground. Nowadays, they do a lot of experiments before they actually start drilling in an area. So first of all, they have to get the data with the energy waves to make sure if it's safe to do it and it's not going to hurt the environment like the Turkmenistan situation from 1971. When they start drilling, they keep adding steel pipes to go lower and lower. When the drill bit goes down, drilling fluid is added to maintain the same pressure, and most of all, it prevents anything from leaking to the hole itself. It also makes the drill work smoother and faster. After all the stones have been removed and all the dirt comes out, they send the cement down, and that means it literally creates a casing around the pipe and drill itself, so nothing leaks in and nothing leaks out. One of the most important things to prevent is to allow water inside the pipe, so the casing is very important. And after the casing, the drill goes down once again. In some situations, usually the first thing they reach is coal. Between the coal, there is natural gas. And of course, between all that, there's a lot of water. The water is holding the natural gas inside it. So the technicians that are working here first have to remove the water from the area. When the water is discharged from the hole, the natural gas starts to flow out because natural gas is very light and it only wants to go up. Natural gas or methane wants to always move up because it's the lightest and it's even lighter than air. So the gas inside the pipe does the same thing. It wants to go up. Fracking or shale gas is pretty much the same thing, but it doesn't just start flowing outwards. They first need to crack the stone down there, or sand. When they create cracks, the cracks allow the gas to start flowing outwards. Same thing with oil. This is the exact reason shale gas and oil is much more expensive to extract than other places, especially the Persian Gulf. And you only find shale usually in Canada and the US. If oil prices go up, the shale and fracking rates go up and they start working. But when oil prices drop, it's not worth it anymore for them to work, so they shut down, and the rigs in the Persian Gulf begin producing more oil. Usually oil and gas is laid out like this underneath Earth's crust. Natural gas is always the highest because it's lighter, and underneath it you have oil, and underneath that you have water. Oil always stays above water, and gas stays above oil. Sometimes the pressure inside the oil well drops, and you can't pull the oil anymore. Back in the day, they were forced to create new wells so they can extract the oil. But nowadays, since the 1950s, they have added natural gas to the well so it increases pressure, and that allows them to pull the oil out. The natural gas that's inserted into the oil well is reusable. It's not like it goes to waste. Before I let you go, let's see the biggest natural gas reserves around the world. This list is provided by the Central Intelligence Agency, the CIA. Of course, in number 1, it shows the entire world which has the most. But the first country is actually Russia. Then we have Iran, Qatar, and Turkmenistan in 4th place. On this list, the least amount of natural gas in a country is in South Africa, and it's in the 104th place. It's weird that the CIA has a list like this. What do you guys think?